Welcome back to my channel Chemistry Made Simple for NEET. I am Dr.Lekshmy Subramaniam with a PhD in Chemistry. I have already uploaded Unit 15 Polymers, Class 12 Chemistry. Today I am going to continue with Polymers and you have got to learn some important concepts from Polymers which is equally important in the view of NEET exam as well. So first of all we'll see what is polyacrylonitrile. So you have already learned about what is meant by polymerization reaction. So polymerization reaction is defined as a process in which two or more monomers engage in a chemical reaction and form long polymer chains or three-dimensional networks. So normally polymerization occurs via different reaction mechanisms which are normally affected by factors like functional groups of reacting compounds and their non-bonding interactions. And you have got addition polymerization and condensation polymerization. So addition polymerization of acrylonitrile in presence of a peroxide catalyst. So actually we are using a catalyst here which is a peroxide catalyst. So as a result of this reaction, polyacrylonitrile is formed. Normally it is used as a substitute for wool, and when we make commercial fibers like orion or acrylan. So here is the equation for that reaction. Acrylonitrile, you are having a double bond over here, NCH2CHCN undergoes polymerization, peroxide catalyst there. Then finally the product is polyacrylonitrile, CH2 here, CH, CN and N times. Okay, so next what is meant by condensation polymerization or step growth polymerization? So here condensation polymerization means it is a repetitive condensation reaction between two bifunctional monomers. So normally these type of reaction results in loss of simple water molecules, alcohol, etc. and as a result higher molecular mass condensation products or polymers are formed. So in such reactions, in each step the product is again a bifunctional species, and then again and again the sequence of condensation will keep on going. So in each step a distinct functionalized species is produced which is independent of each other. So this process is also called a step growth polymerization. For example, the formation of pterylene or dicarboxylic by interaction of ethylene glycol and terephthalic acid. So you can see here ethylene glycol NHOH2C, we write CH2OH like this in the reverse order, and then another CH2OH like this. So it reacts with N molecules of terephthalic acid, then benzene ring on either side we attach COOH group. Then you can see in the product pterylene. So this benzene group we write it here COCO. So 2 times, and then here N times, and then left hand side again CH2O. So this product is written. So this is an important equation which you have to remember. Then what is meant by polyamides? So here such type of polymers have amide linkage, and these are important examples of synthetic fibers, and these are called nylon. You might have all heard of nylon. We make clothes and all using nylon, which is a synthetic fiber. So normally general method of preparation means condensation polymerization of diamines with dicarboxylic acids and also amino acids and their lactams. Then how is nylon prepared? Nylon 6,6 normally prepared by condensation polymerization reaction itself. What are the reactants? Hexamethylene diamine with adipic acid. So normally high pressure is used and also high temperature. So under the condition of high temperature and high pressure nylon is formed. So you can see NCOOH. Then this reaction you can it's given in the textbook as well. This is a very important reaction. NCOOH, then here CH2 4 times COOH plus NH2N CH2 6 times NH2. Then temperature is 553 Kelvin and high pressure. So the product formed is here you have got NH, then CH2 6 times, again NH, C double bond O, CH2 4 times, CO, that is N times. This product is called nylon. Usually it is used in making sheets, brushes, bristles and in textile industries. So preparation of nylon is also very important. Just go through these important notes and the equations. Now nylon 6. So nylon 6 is obtained by when we heat caprolactam with water at a very high temperature of 533 to 543 Kelvin. So here you can see the structure of caprolactam, CH2, NH, CO, CH2. This is a ring structure, CH2. Then again in the product side nylon is formed, CO, then CH2 5 times, NH, N times. So N molecules are formed. Normally it is used in the manufacture of tire, coats, fabrics, ropes and all. Now preparation of polyesters. So polyesters are normally polycondensation products of dicarboxylic acids and diols. So normally the best known example of polyesters can be dacron or terylene, and normally we heat a mixture of ethylene glycol and terephthalic acid at 420 to 460 Kelvin with zinc acetate antimony trioxide catalyst, and also terylene is crease resistant. Normally if you use cotton clothes and all that, it gets wrinkled easily and you have to iron it before every use, but here it is crease resistant and we can blend it with cotton or wool fibers, and also used as glass reinforcing materials in safety helmets and all. Then how is phenol prepared? So it's also called formaldehyde polymer or bakelite and related polymers. So normally phenol, formaldehyde polymers are the oldest synthetic polymers. Normally we make it by condensation reaction of phenol with formaldehyde with either an acid or a base catalyst. So initial formation of ortho or para hexamethyl phenol derivative is the starting of the reaction. Then again this will react with phenol to form ringed compounds which is joined to each other through CH2 groups. So initially we can get a linear product Novolac which is used in paints. So you have to importantly study all these topics because it's very important. Next you can see the reaction of formation of phenol reacting with CH2O, and in presence of H plus or OH minus we get OH. Here CH2OH plus again OH, you can see CH2OH getting added over here in ortho meta para position here also. So then here N molecules of OH CH2OH, this one will again in presence of OH plus gives CH2 like OH CH2 OH CH2 OH CH2 because linear straight chain structure. This is called Novolac. Then next Novolac, what will happen on heating it with formaldehyde? It will get cross linked to form infusible solid mass called bakelite. Structure is very important and it's very easy as well. You can see this way and this way. So same structure. So CH2OH, 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 CH2 again in the middle all CH2 is coming, again all CH2 here, then bottom also all OH. So normally bakelite is used in making combs, then records, switches, then handles of utensils and all that. Now melamine-formaldehyde polymer is formed by condensation polymerization of melamine and formaldehyde. Melamine, you can see nitrogen, here double bond, 3 nitrogen atoms, then here 3 places we have NH2 plus formaldehyde HCHO. It gives, again you can see the product, this part is same, then here NH2 is same, here you get NHCH2OH. It is a resin intermediate undergoing polymerization reaction. We get melamine polymer So here NH, then again N in this structure, bottom also NH. Instead of NH2 we have NH here, then again here also NH. CH2OH will go, we have only CH2 N times. Okay, now copolymerization. So normally what is copolymerization? It is a polymerization reaction. So more than one monomeric species is led to polymerize and a copolymer is formed. It is formed normally copolymer is made not only by chain growth polymerization, but there is another process also called step growth polymerization. So there are multiple units of each monomer which is used in the same polymeric chain. And example, a mixture of 1,3-butadiene and styrene. So they can together form a copolymer. So you can see here styrene CH2. So NCH2 CH2, it is 1,3-butadiene, and product side is CH2 CH2 CH. Here we are having a ring structure, CH2 N times. So it is a copolymer. Then rubber, it's very important. Rubber, as you all know, is a natural polymer. It has got elastic properties. So we can also call it an elastomer. It's having lots of uses. So manufactured from rubber latex. So it is a colloidal dispersion of rubber and water. And the latex, from where do you get the latex? From the bark of the rubber tree. Normally it is found in India, Sri Lanka, Indonesia, Malaysia, South America and all that. So natural rubber is actually a linear polymer of isoprene and is also called as cis-1,4 polyisoprene. So natural rubber structure is very easy to remember. You can just go through this structure. The cis polyisoprene, it has various chains held together by weak van der Waals interaction. So it has a coil structure. So we can just stretch it like a spring, and so it shows elastic properties. And what is meant by vulcanization of rubber? So natural rubber becomes very soft at high temperature, more than 335 Kelvin, but at low temperature it gets brittle. So on vulcanization, what happens is that you can see in the figure, sulfur will be forming at the cross links at the reactive site, and so the rubber will get stiffened. So this is the probable structure. You can see it over here. Then how can you prepare synthetic rubber? So neoprene is one example. It is also known as polychloroprene by free radical polymerization reaction. So you can see the reaction over here. NCH2 double bond CCl CH double bond CH2 undergoes polymerization. You get CH2 CCl double bond CH CH2 N times. It's known as neoprene. It has got a high resistance to vegetable and mineral oil. So it is used to manufacture conveyor belts, gaskets, hoses, etc. So what is Buna N? So already you have studied about Buna and Buna N is got by the polymerization of 1,3-butadiene and acrylonitrile in the presence of a peroxide catalyst. So the reaction is 1,3-butadiene NCH2 CH double bond CH2 plus N times CH2 CH CN. Copolymerization reaction takes place, and the product you get CH2 CH double bond CH CH2 CH2 CH CN N times, which is known as Buna N. So with that we come to the end of this session, and always remember that while preparing you have to mark out the concepts which you personally find difficult in every chapter. Spend more time revising and solving questions based on these concepts, and write down the complex formula and keep reading them over and over again in the last few days. So we all study in our own unique ways, and some study with the help of graphics, and some try to relate the concepts with real life situations. Use whichever works the best for you to crack the NEET 2022 exam. So with that we come to an end of this awesome section of polymers. We have come to the end of this lesson, and soon I will be uploading my mind map as well as the MCQs based on this lesson. So keep watching, and please share it with your friends and subscribe to my channel, and wait for my new videos to be uploaded, and press the bell icon as well, so that you will know immediately as soon as I post new videos. And thanks for watching.